We begin this introduction to polynomials with some vocabulary. The word monomial usually refers to a term or a single term. Binomial, that's got the prefix bi, refers to two terms. Trinomial refers to three terms. And you're probably used to, from your English classes, thinking of the word or the prefix poly representing many. It can refer to many terms. So I'm going to write it, but I'm going to say or it can refer to any of the above. So for example, if I have 3x plus 2y, that typically is called a binomial because there are two terms, but it can also be referred to as a polynomial. It's kind of like using the word y'all in Texas. Sometimes y'all can refer to one person, sometimes y'all can refer to a whole group of people. Same thing here, a polynomial can refer to one terms or a whole group of terms. As far as this vocabulary goes, I know this looks a little bit confusing here, but polynomials are written in descending order. Let's say we have x to the fifth, then x to the fourth, then x to the third. If we start with an exponent of n, we subtract 1 to get to the next exponent, and then 2 to get to the next, etc., until we have x to the first power, and then that last number there. This a out in front is called the leading coefficient, and the d at the end, sometimes we use the word trailing, but it generally is just called the constant term. It's constant because there's no variable attached to it, and that's just a number stuck at the end. So let's use this vocabulary in a few problems. We've got this polynomial. Notice it starts with an x to the seventh, drops to x to the fifth, drops to x to the fifth, etc. The leading coefficient is just this 5 out in front. The constant term is the negative 11 that's down there at the end. What is the degree of the second term? Well, the degree of the second term is going to look at that second term, 4x to the sixth, and it will be the exponent in that term, which means the second term is of degree 6. As far as the degree of the polynomial is concerned, we look at each of the terms and we find the highest degreed term. Well, since the first exponent is the largest, that means the first term will control the degree of the polynomial, and the degree of the polynomial will be 7. Now, if a term has more than one variable, its degree will be the sum of the exponents. So for an example here, notice in this expression we have both an exponent of 2 and an exponent of 7. The degree of that term would be 2 plus 7, which would be 9. That would be a 9th degree term. We then move on to adding polynomials. When you add polynomials, essentially all you do is combine like terms. So we're going to combine the x squared terms first. 3 plus 7, adding the coefficients, gives us 10x squared. We go to the x terms. 5x plus negative 9x makes minus 4x. And then the constants, negative 2 and positive 13, add together to give us 11. And we're done. That's it. Moving on to the next exercise. Sorry there. This time we're adding in a vertical format. We don't have to worry about starting on the right because there'll be no carrying to the left. We just add down in the x cubed column and get 13x to the third. In the square column, 3 minus 9 makes minus 6x squared. In the x column, all we have is that 5x, nothing above it to add to it. And in the constant column, we're going to have plus 8. 11 minus 3 makes 8. When you're finding the perimeter, that just means add up all the different sides. My suggestion would be to put a starting point here so you don't accidentally add something twice. 5x and 8x add up to 13x, plus 6 more makes 19, plus 6 more makes 25, plus 8 more makes 33x. I would then move on to my constants. I start with a 3, plus 2 makes 5, minus 4 makes 1, minus 4 more makes negative 3, plus this 2 here, negative 3 plus 2 makes minus 1. And that then would be the perimeter of this funny shape. When it comes to subtracting polynomials, you've got to be careful that you distribute this negative. There's a negative 1 understood to be in front of that second parentheses. The first parentheses has no number outside it, so there's really no purpose for these parentheses other than separating the first polynomial and saying this is the first. So I'm going to drop off the parentheses and just write the stuff inside down on the next line. And then I'm going to distribute the negative here and have minus x squared. Negative times positive makes minus 7x. And then negative times negative makes positive 4. Then we combine like terms with what is left here. And with the x squared terms, 3 minus 1 makes 2, so 2x squared. 5 minus 7 makes minus 2x. And 11 plus 4 makes plus 15. And that would be our answer because nothing else can be combined together. I'm not too wild about doing subtraction in a vertical format, because if you write a minus sign right out in front there, it only looks like it's going with the 2x cubed, but you're really meaning to subtract that whole bottom row. So what I suggest you do is you distribute that negative through, changing the signs of each term along the way. Don't take that minus sign and put a bar through it to make it a plus sign, because then you can't tell the difference between the original problem and what you put into the problem. I suggest you just put them up a little, above a little. And then once you've kind of created the opposite, we're going to add the opposite, and that will be our subtraction. So 5 minus this 2 will make 3x cubed. In the x squared column, negative 2 plus a negative 7 makes minus 9x squared. We're then going to have plus 15x and minus 17. So that's all there is to adding and subtracting polynomials.